do that. There's no way to escape.
Yeah. Thank you.
So you're a Scrum Master or something like that.
Hi, everyone. Hello. Thank you for sticking all the way to the end of today's program here at KGC. I don't know about you, but I'm a little bit tired, so hopefully I'll be able to keep my energy up for this one. Been waiting for this. I've never thrown a workshop about workshops before, so please bear with me. Okay. Couple of disclaimers before we start. One is I have a severe hearing disability, so if you have any questions, raise your hand and I will come to you. And the other thing, that all my workshops have a computer ban. So pack away your computer, please. Yeah, you're okay, because we need to, those following online can keep their computer. Doesn't have to pack away that one. But I want everyone at home to find a pen and paper.
If anyone has a question, you can ask on the microphone.
Microphones, I love them. So I didn't have anywhere to stick that microphone thing, so I have to carry it in my portable pocket. But yeah, anyways, let's begin. My name is Veronika Heimsbakk, and it's actually the third time today I'm presenting myself. I am currently knowledge graph lead at Capgemini in the Nordic countries. Myself, I come from the cold mountains of Norway, and when I say mountains, I really mean mountains. It's like tiny, tiny village up in the mountains in the middle of Norway. And how I fell into this subject of knowledge graph is that I went to the university in Oslo, and on my first semester, I met perhaps one of my largest mentors, which also became a great friend of mine. And he was having this course on logical methods for informatics, which was about set theory and functions and first order logic and all that stuff. He sadly passed away 2 months ago, but his teachings are still with me, and he's also the best outreach I know. So everything I do in communicating, I've learned from him. Anyways, fell in love with logic, discovered semantic technologies. I can apply that theory of logic onto something practical, and here I am. So I've been doing knowledge graphs for about 10 years now, and 5 of them at Capgemini. And today I'm going to talk about workshops. And it is a workshop. See pen and paper in front of you, so you're going to have some activities during this session. And why am I doing these kinds of workshops? Well, there are plenty of reasons why, but some of them is to outreach the wonder of semantic knowledge graphs, making people aware that this exists and has been and it has existed for quite some time already. To raise awareness of the importance of knowledge in a world of predictive madness, and that AI is more than machine learning. I don't know about you, but when I see people, and perhaps especially middle management folks and business leaders talking about AI on LinkedIn or in the news or wherever, I get the impression that they think that AI is equivalent with machine learning and neural networks and those kind of techs. But AI, as you probably all know, is this huge group of disciplines and technologies, and knowledge representation is one of them, and the reasoning is another. So I think it's important to say that AI isn't just machine learning, and especially with one of my hats in Capgemini, because I'm also the go-to-market lead for public sector. And the public sector in Norway, at least, has gotten a lot of money to any project that you can tag with AI. So if I can say that knowledge graphs are AI, I get money to do the fun projects. Anyways, so who has been my audience in this workshop? So I started approximately 3 years ago doing these workshops, and I've done a couple of ones at least, and even more after I made this slide. So the Norwegian police force, they showed up with 50 people, from Python developers to information architects to business leads to police folks. That wasn't techie at all. So that was fun. The Norwegian Digitalization Agency, they invited 8 different agencies in the same room to talk about RDF, especially DCAT, and the Norwegian Common Data Catalog, which is based on DCAT. Done a lot internally in Capgemini, and of course the Norwegian Maritime Authority, which is like my child, and also been hosting workshops at Scania in Sweden. We have created this Knowledge Graph Oslo meetup group with 260 members already, and we started last summer. I've done like a drawing workshop for them as well. And Bane NOR, the Norwegian Railway Service. And since I made this slide, also the Norwegian tax authorities. Okay. So first of all, what is the content of such a workshop? And what time do you have available? Well, when I started, I tried to like fit into the client needs, but I quickly discovered that this became too much work to redo content every single time. I still do some narrowing down on some parts of the content to fit the client needs and the client domains, but my main outline is still the same. I'm still talking about the same stuff, the same things. It's RDF and friends. So my smallest workshop, that's, is there like a laser on this thing? Oh, cool. Okay, I haven't played with these before, so this is new to me. Okay, so my smallest workshop is at 2 hours. And in 2 hours, we are going through observations and motivations. We're going through a small introduction to RDF, and we're doing hands-on drawing. And if time, we'll also go through RDFS without inferencing. So we classify our drawing in the second drawing session. And then it's the end of the workshop. And usually the discussion gets so lively that we almost don't make time for classifying our drawing. The beginning is the same in all the different setups of my workshop. And the second one is 6 hours or a full day. The same beginning. I'm actually the first things here we are going to do after I'm done with talking about the meta stuff around the workshop, we're going to do a part of the workshop. And you are going to be with it. Yes. So the 6-hour one, after classifying the drawing, and in this case, I do some inferencing introductions also. So after classifying the drawing, I talk about vocabularies and well-known vocabularies and where to find them. So it's it's a bit pain to find those meta collections of available vocabularies and ontologies, because there aren't any good meta collections on ontologies that captures really a lot. You have it for specific domains, but what about just gathering something in a huge engine of ontologies? Perhaps. So I had this cry on Twitter once. Yeah.
For the collection.
2 seconds. I need to come to you.
The microphone. So for the collection of vocabularies, the late open vocabularies, 847 doesn't help?
Yeah, it only contains a subset of everything available anyhow. But as I was going to say, I made a cry about this on Twitter a year ago or something. And luckily, a lot of knowledge graph nodes are on Twitter. So I got like a Twitter thread. So my Twitter thread is a meta collection of meta collections. So I paste a link to that thread in my workshops. And then I have a visualization, which is colored, showing all vocabularies that can be in play, describing a small set of concepts. After lunch, I have a little notion on LPGs and the difference between LPGs and RDFs. A lot of terminology. We skim through OW quite quickly. And then I'm showing a hands-on demo on OW. So then we're taking a drawing into Protégé or Web Protégé. And then I leave a consistency breach in my demo and ask the audience if they can discover it. Question? No? And then I skim through Shackle. So the purpose of this is not to be like experts on knowledge graphs, but know what it can offer, right? And if time, I talk about a project implementation. And this 6-hour thing is almost the same in the 12-hour thing. I've just put in Sparkle also, because Sparkle takes a lot of time. So the main difference between the short one, the 1-day one, and the 2-day one is Sparkle. And I'm leaving more time on hands-on exercises in the 12-hour one, opposed to the 1-day one. So I've gathered together there's my water, a summary for my topics after the hands-on drawing, because we are going to do the top thing today. So I've collected a summary. Oh, yeah, first of all, more scoping of the workshop. So usually a classroom setup, that's why I have demolished this room from the regular lines into groups so that people can work together. So now I want to spend 2 minutes. So if you're sitting together with someone you know, remove yourself and find a person you don't know and sit together with that person. Okay, 2 minutes, rearrange, please. I know that group back there knows each other, so they have to move at least. And stick together, because we're going to work in groups. So sit together, so you can talk.
I think it was before.
We need to leave this there.
No, if you want to have a workshop, can we switch as presenting? Oh, okay.
Probably.
You wish,
You sit over there, it's technically. Yeah.
Wonderful, we were waiting for something because we don't know each other, like, wait,
Great. You're talking already. Amazing. Okay, but I have more things I want to say. So if we can keep it down till the end, because there is enough room to talk on the hands-on part of things. Unless you find this information very boring and you just want to chat instead, of course. Anyways, have a whiteboard accessible, because you do want to explain terms and concepts within knowledge graphs, drawing in front of the audience. When I'm setting up a workshop and I'm alone hosting the workshop, I say maximum number of participants is approximately 30 people. Because in the hands-on exercises, I need to be there to assist them. And I walk around on every single table and says, hvordan går det her? Eller, how does it flow here? Or something. Usually do it in Norwegian. Start to pick their brains. So they have selected a topic among them. I start to draw concepts and the relationships between the concepts. And I ask them, what is this? And does that arrow really go there? Doesn't it go there? And stuff like that. Mixed audience. If the audience is from different kinds of organizations, I ask them, or I let them choose their own topic. So they can draw a graph of their favorite movie or book or band or whatever. But if the audience is within the same subject area, I force them to draw a graph of their own domain in question. Yeah. So the main goals of the workshops. The 2-hour one is how to think in graphs. As easy as that. Nothing else. I don't expect much from people. And the 6-hour one, understand the semantic web technologies and their capabilities. We're not doing a deep dive into the different standards, just to show what's out there and what are the capabilities. Like you can use OWL for inferencing and reasoning. You can use Shackle for validation. There do exist some query language out there, but I don't know nothing about it. But after the 12-hour one, I would expect the ones attending to be able to assist an ontologist, not to do the work themselves, but be able to assist and understand what's going on. Okay, and another thing, yeah?
well here?
Yeah.
Okay, so normally you were saying that you had like different types of people attending these events, these workshops. Usually they're not going to be familiar with ontologies, with knowledge graph, or anything at all. So, okay, that's great.
That's what I was going to say next.
Oh, sorry.
Yeah. So I always look at my audience as they were kindergarten kids. So we're keeping it low threshold. That's why we have paper and coloring pencils as our tools of trade. And I do even that for business leaders, bringing coloring pencils on paper. And I was warned by my leaders and management at Capgemini not to do that. Because if the business leader feels that they can't complete the task they're set to be done, they will feel dumb. So do not do that with business leaders. But I did it anyhow, and they managed to create a graph of their own car. So that was fine. Talking about tools of trade, For the 2-hour session, A3, I don't know if that's a metric that computes with Americans. No, that's twice as A4. So this is A3. Yeah, huge paper sheets. Yeah, so I'm talking in the metric system. And coloring pencils. I don't just bring boring ink pens. I bring coloring pencils and sometimes stickers, but never glitter. I have a 5-year-old daughter, so I know how awful glitter is. Anyways, on the 6-hour workshop, we also use Protégé and Clash or Web Protégé. I do a demo on both because they have different kinds of functionalities. And I do the reasoning thing on Protégé, of course, because Web Protégé doesn't have any reasoning functionality yet. And for the 12-hour one, we play around with Fuseki. We set it up, run it, look at the endpoint, upload our drawing into Fuseki, and do some queries on it. Or for those who are struggling with Java environment paths, can use the Wikidata Sparkle endpoint, which is also quite nice. And also, in the 12-hour one, we're doing some shackle by hand ourselves using the shackle playground. Okay, so now for my summaries. So I've taken, here I've taken all the slides regarding RDFS and tried to put it into one or two, perhaps. So it might look much to you here, I know, but I tried to make a summary of my content. So at this point, we know how turtle looks like. We know how a triple looks like. So I can start introducing RDF resources because I have established that as a term, RDF resources. Anyone here doesn't know what an RDF resource is? Okay, you two are excused, but the rest, perfect. That's good. Okay, so I talk about the most used resources from RDFS. The resource, of course, class, property, even though it's not RDFS. Actually, I was working, oh, it might be a bit cruel to say. Okay, I was working at a client in the public sector of Norway, and some other consultancy firm has been there creating RDF for them. And I was going to parse that RDF, and every single time they have used the property, they have been using RDFS. So I wasn't able to parse that data. Yeah, so I highlight that property is from RDF. And then we talk about RDF type, domain, and range. And I talk about property semantics when I talk about domain and range. And I usually draw it on a whiteboard how domain and range works, because that's easier to understand. And inference, I explain the transitive relationship, because that is fancy enough and easy enough to show off what RDFS inference can do for you. And in that case, I'm doing subclass and type. Jupiter is a type of planet, and planet is a subclass of astronomical body. And if those two triples were everything I knew in the entire world, and I'd put the RDFS reasoning on, the reasoning engine would then create a new triple for me, saying that Jupiter must be a type of astronomical body. So that's a transitive relationship. And I'm going very slow, and I'm explaining this in my workshops. Not that slow that the audience feels dumb, but slow enough for them to catch it. And I take a pause and I ask, are you with me? Henger dere med? And I get careful nods around the audience, and that's enough for me. And I put in the notation for those who like stuff like that. And then we have a hands-on classifying the drawing So the first drawing session is not bothering about namespaces, not bothering about the difference between instances and classes and stuff. It's just to get the graph thinking in your hands and in your heads. So now we're classifying the drawing. And for those who want to, add domain and range. And then I talk about vocabularies, and I talk about a few definitions, because especially in my world as a consultant, meeting many different people with different kinds of competence level on the field, these words, vocabulary, taxonomy, and ontology, could be used for the same thing, could be used for different things. I don't know. So I try to establish a crisp and clear and short definition of the different terms. So what I say, and you might disagree with me, but what I say is that the vocabulary is just a collection of words, like a dictionary. A taxonomy is categorizing of those words, grouping those words together. And an ontology is establishing relationships between those words, applying logic to that list of words or categories. And then I list a few well-known external vocabularies and give short description of them, like FOF and DC terms and FIBO, unit, which has become one of my favorites the last years, and DCAT, of course, and a couple of others. I here again repeat the value of global unique identifiers. Again, I repeat that a lot. Global unique identifiers of things, the URIs. Yeah, and I give the reference to meta collections of vocabularies and ontologies in this slide also. And for the long version of the workshop, we look at Sparkle, but we do not have time to look at full Sparkle, of course. Everyone who has been to the Sparkle specification knows that the table of contents is at least 20 kilometers long. So it's no time to go through full Sparkle, but it's time to get to know the graph pattern of Sparkle. It's quite similar to Turtle in a way. You just put a question mark where you want something in return. So I go through some popular keywords, and I include a lot of examples, both in the slides and also hands-on demo afterwards. I talk about the most used triple stores on the market, and I use my own experience working with those kinds of triple stores. Because I don't think it's a one size fits all out there. So vendors focus on different things. They have different functionality available. I try to keep myself updated with what's out there, but things are happening quite fast these days, aren't it? Yeah. And if you do not have any experience with any of the vendors available, try to upscale yourself a little bit, because you will get questions about what kind of shelfware is out there, what kind of platforms and databases are there, and what can they do for me. And there's a lot of great content on YouTube to investigate in this matter. Hands-on, we now know Turtle. We are typing our drawing into a text editor of choice. So this is like in with a teaspoon, because we're going to know where it comes from, right? And we then upload that into Fuseki and do queries on it. And then, keep it short. owl is intimidating, but I want us to try to make it less scary for somebody that is new to knowledge graphs and new to ontologies. So I bring in this handsome guy over here to help me with the definition of ontologies, because ontologies is definitely nothing new. If knowledge graph isn't new, ontologies are ancient. So I usually go like this. So the boring definition of an ontology is that it is the explicit specification of a conceptualization. It's the study of existence, categories, and relations between what is. But in computer science, it's formal names and definitions of entities, properties, and relations. And my workshop often leads to a more hardcore ontology modeling workshop after you have gotten the sense of graph thinking and being able to apply that accessible semantics in your graph data structure. And this is my intimidating slide. I do not expect the audience to understand what this is saying, but I have experienced that this is a good reference for many of my attendants. So I go through the different kinds of characteristics the object property could have, and I try to come up with some feasible example. And then also the set theory behind or between classes. So in RDFS, when I start to talk about classes and instances in classes or individuals, I always link it to set theory. So I use class and set. Oh my God, my English words disappeared. But I use them, yeah, you know what I mean. Yeah, thank you. And then I use instance, individual, and element as synonyms for that thing that it's typed a class. Because I often find that those developers in my audience, they have had a little bit of discrete mathematics in the university. So I try to link it up to the logical terms when talking about OWL specifically. And for the hands-on, I do a follow-along demo for the 6-hour one when I type in my drawing to Protégé, and they can follow along me, or they can follow along for themselves with their drawing. And the purpose of this is get to know open source tools for semantic modeling. So it could be Protégé, Web Protégé, it could be Workbench, it could be anything else. But I use Protégé and Web Protégé. And in my demo, I always leave a contradiction. So what I do is I create the classes of planet, dwarf planet, and natural satellites. And I make all of those classes disjoint, because nothing can be an intersection between any of these classes. And then I create a relationship that I call moon, with the domain to planet and dwarf planet, and the range to natural satellites. And then I create some elements, Mars, Pluto, Styx, and Phobos. And then I set the relationships. And then I turn on the reasoner engine and I ask, uh-oh, what went wrong? Because Protégé is trying to explain me something. And then I dissecate. I strip down this thing and explaining them the issue here. Of course, I want a relationship moon between planet and natural satellite and dwarf planet and natural satellite, because that's reality. Both of those things can have a moon, but nothing can be both a planet and a dwarf planet at the same time in this world. So the domain here points to the empty set that can never be used. So a solution here is then to put in another abstraction layer, planetary body, for example, and put it surrounding planet and dwarf planet. So those two will be then subclasses of planetary body, and you update the domain of your relationship. So that's my contradiction example, and I approximately spent 20 minutes explaining that one. I also have additional demo on classification by reasoning. I have downloaded all the data of hydropower plants in Norway and their capacity. And then I classify the power plants based on capacity, because you can be a micro power plant, small power plant, mini power plant, and so on. And I also have a similar one for stars, where I classify stars based on the Kelvin temperature. And I can share those files after the workshop if you want to have a look or reuse them. So the reason for that is to display how owl axioms works in Protégé and how they look like. Shackle. Any of you have seen me and Ivo's Shackle wiki? Woo! 1, 2, 3. Of course you have. Yeah. 3.5. Yeah. Nice. So my slides for the Shackle stuff looks very much similar to the stuff on the wiki. And why is that? Yes, the wiki was created from my Shackle masterclass, or most of it, at least. Anyway, I walked through the core constraint components quite fast, categorizing the different core constraints, explain how a Shackle engine works, and show an example of a validation report. And for the 12-hour workshop, I used the Shackle playground. And when I'm closing up a workshop, you go for a project presentation from one of the Capgemini projects that are in production using knowledge graphs for various reasons and use cases. I put in a reference architecture, and I made this image very small because of reasons. It's a bit outdated, so I'm going to update it before I'm sharing it with the world. It's 2 years old. And then similarly mapped a vendor landscape and tooling to that reference architecture. And when I'm selling stuff for my company, I brag about our Knights of Knowledge community, and I can do that now also, and all the fabulous colleagues I have working with knowledge graphs on a daily basis, and a little bit about our clients and their use cases. And after the workshop, and I find this quite important, I always send an email to everyone that was in the audience saying thank you, providing references, the slide deck, and a lot of links to further reading. And then lately, I have used this course at OpenHPI on knowledge graphs, because that's available for free and it has quite good content. So that I share. And I also share, but that's only in Norwegian, sadly. It's that logical methods for informatics is available on YouTube in Norwegian. So I share that also. Okay. I need some water. So some important things to remember is to smile. I know it can be super hard to go and be happy for such many hours in a row, but that does something to people, being happy when you are outreaching the technology that you like so much. Move around and have a welcoming body language. Don't stand like that and don't stand still. And be confident. You know this content way better than the audience, usually. I remember, I think it was 2 years ago, I was having a presentation on Otter here at KGC, reasonable ontology templates. And I was super nervous because I'm always nervous before I present new content. But I said to myself, I am the one at the whole conference that knows reasonable ontology templates the best. But then I saw a Danish guy from a pump company in Denmark that uses Otter on a daily basis. And I was thinking, oh no, what have I done? But it went fine. So sorry, Mikkel, you scared the shit out of me. But I got through it. Be consistent in your terminology. It's okay to use synonyms, but when you're using synonyms, link them together in your language. So they don't have the impression that instance and individual and element are 3 different things. We're actually talking about the same thing. So that's important. We have a lot of words for describing the same stuff in knowledge graphs. Make room for explanations. Take pauses. People have questions, and people want you to elaborate on things they didn't catch or want to know more about. So make room for explanations. And in this case, that whiteboard comes in handy. And this one took a long time for me to overcome that one. It's okay not to know the answer of a question, but one should know where you can find the answer. Ish. And a math teacher told me there are no stupid questions, only stupid answers. So don't pretend you know the answer if you don't. It's tempting to try to answer, but it's okay to say, I don't know. But you might find your answer on this webpage, for example. Take enough breaks. This is super difficult to remember. I'm not thinking that my audience needs water or coffee or go to the bathroom. I'm just like a train on my workshops. I forget time and space and everything. I'm just in my own bubble. But it's so important to take breaks. And be enthusiastic. Have fun. I find knowledge graphs very fun. And I think I'm able to smitten that over to my audience when doing those interactive workshops and get the discussion going. And that's like a natural break also from the slides, because slides are so tiring. I'm doing something practical instead. I'm creating a discussion. Keep it simple, inspire curiosity. And with that, we're going into the workshop. So this is the slides I'm using. Does anyone need to go to the bathroom or find some water before we move on? Shall we do a break? Okay, let me see at my clock. Okay, you get 4 minutes. 4-minute break. Perfect. I'm going to turn this off. Where am I doing it for?
basic question, but like, when you wondered, you're saying that at the end of the day, like, people ended up helping kind of like.
Yeah, on the long one. Yeah, but most of the workshops I do is the one day thing, you need to know semantic knowledge and know the capabilities applies within.
Oh, so it's for them to learn about like.
Yeah, to be inspired to explore the.
Like, not a workshop aiming at helping a certain organization, like build or like make.
No, that's the
create
next
product.
step. That's the next step. This is introductionary.
Oh, okay, so you did that.
Yeah,
before you-
so this is. This is how it works, and this is what they can do. If you want to do it, schedule another one.
Of course, I mean, on this side as well. Oh. My first time I did my first time here. Yeah, well, no, yeah,
No, it was like, trying to get that in the first place. So, I don't know. Yeah, I'm like trying to learn from here, but also like trying to make like a product.
So we're going to do the workshop now, up until the first joint session.
I went there. Yeah. Hop on, hop off. I totally agree. With the view of the rivers, it's very pleasant.
Why are you talking like outside? We make a lot of yeah.
The break is over. Okay, so everybody had a nice break. Awesome. So look at that, I can remember the scheduled breaks. Yay. Yeah, okay, so now I'm going to do the workshop for the first few sections of it, at least. And I usually do it in Norwegian, but I have an English version of it also, because not all my clients are in the Norwegian public sector, but most of them are. Anyways, okay. Welcome, blah, blah, blah. I've already done that. So I tend to start with an observation. And it's not only me that have done this observation. And between us, I actually stole this from the panel discussion at Semantics in 2022, is that when we think about data, or not you at least, but most people, when we think about data, we tend to think in tables, in rows, in columns, and cells, in spreadsheets, and SQL databases. But, oh, where's the clicker? Where is the clicker? But when we talk about data and when we talk about information as humans among us, we use natural language. And natural language is built up by subjects, predicates, and objects. And that's exactly how we structure data in a semantic knowledge graphs. And a typical example of such linked data, we saw this predicate as an arrow, right, between two things going in a certain direction. And that we can call linked data because it's linked. And a typical example of linked data is Wikipedia, because this is something everybody has some kind of relationship to. I don't know about you, but I have often find myself in this Wikipedia hole way too late in the evening, just clicking and clicking and clicking and clicking, and suddenly I know everything about every single king in England. Yeah. So Wikipedia, it's HTTP documents, or it's documents with like this HTTP URL, right? Linking to other HTTP documents, linking to other HTTP documents and other HTTP documents. But what if we took those HTTP names and didn't just use them for documents on the web anymore, but we use them for things, for persons, events, actions, vessels, cars, whatever. And that is also something we do in a semantic knowledge graph. And we're going to see a lot of examples on that in this workshop. I usually say that a knowledge graph, it works like a unifying logical language for data that is equally interpretable by both humans and machines, not dependent on natural language. It's quite a long sentence. I repeat it a lot. So the machines, they understand those HTTP names, and you will understand in a bit what the humans understand. But humans read text in different kinds of languages, and we can annotate anything in a knowledge graph in any thinkable language, even fantasy languages, if you like. And a unifying language for data. So I don't really care how the data looks like or what shape or form it is in when I get it. I can work with anything as long as it contains usable information and data to serve my applications and to serve the client needs. I can transform that data into a connected bush of information with accessible semantics. So, but what are semantics, right? And this I actually stole from Ura Lasilla. Was it last year at KGC, or was it the year before? I don't remember, but he had a nice thing about the semantics and JSON, so I stole that one. I don't say I stole it in my workshops, but I tell it to you. Okay, so semantics, what is semantics? And here I ask the audience if anybody knows what semantics means, because semantics isn't a word that everyone has in its daily vocabulary. So it's a mystical word perhaps. It's a bit scary. Knowledge graphs, it's much safer. Semantic knowledge graphs are a bit scary. But semantics is just the meaning of things. Being able to capture the meaning of things directly in the data layer. But what about JSON? Doesn't that contain semantics? Well, everybody here are able to read and understand what says on this slide. Even though you don't write JSON, you can understand what it says. But if I gave you this to begin with, you probably won't understand it unless you're from Hungary. So the point here is that a lot of the data formats and exchange formats we use for information. You're from Hungary? Yeah, nice. I hope Google Translate did a good job. Yes, great. So the point here is that most used exchange format of data are dependent on the sender and the receiver and what kind of natural language they use. What if we had an exchange format for information that wasn't dependent on natural language, that used URIs instead? Anybody know what that can be? It could be RDF. I'm just going to have a look at my timer because I want you to draw also. Okay, I'll skip this because I guess that you know the deal here. So the point of this slide is to establish that this thing isn't something new and scary. We've been doing this for quite some time. So I start here with the World Wide Web and I end there with Chaco. And then I have this thing. When I started, okay, so now I'm not in workshop mode, but in information mode. So when I started diving into semantic technologies, I had this stack picture with all kinds of noisy things surrounding. I'm sure that picture is still out there somewhere. So I decided to strip away everything that was web related in that stack picture and kept it to the usual suspects that makes out semantic knowledge graphs. Okay, so in the bottom here, we have global unique identifiers for things, those HTTP names that we're going to look at. A knowledge graph can be written in many different syntaxes. You can serialize a knowledge graph in many ways. And back in the day, RDF XML was the most popular one, but nobody bothers to read XML anymore. So luckily, today, Turtle is the most popular one. So when you're Googling for information or reading papers and blog posts, it's Turtle you will meet. So that's what I'm using in my slides also. The foundation in a semantic knowledge graph is the resource description framework. It's a quite simple standard specification. It only tells you how to structure data as a directed graph, meaning that that link between two nodes go in a certain direction. On top of that, we can build class hierarchies using RDF schema. And then we can build ontologies with the web ontology language, applying logic into our class hierarchies. And we can put constraints and rules on our data using the shapes constraint language. And we can query everything with Sparkle. And here I tell the story about why Sparkle is a recursive abbreviation. But all of these standards, they have different capabilities, but everything is just written in triples using the same syntax, using URIs as unique global identifiers for things. And then I put in this thing. So this is something I drew last year because I was annoyed about all the people on LinkedIn talking about AI as it was equivalent with machine learning. I've already had this rant for you, so I won't do it again. But I say something about the main goal of AI is to achieve general intelligence, like the Terminators and everything, right? But in order to get there, if you want to get there, we have to overcome several sub-goals to make the machine learn different things. And actually, if you go to Wikipedia and read the English article named Artificial Intelligence, the first goal you will read about is reasoning, right? And how do you achieve reasoning in a machine? You build ontologies, and you have to represent your knowledge which is the second sub-goal. So this I rant a bit about before I go on to resource description framework. And we'll go a little bit quickly here because I want you to draw. So think about data as directed graphs, and that all things has a relation to other things. So I want you to forget everything you know about tabular data, about spreadsheets and relational databases. Now we're thinking about data as directed graphs, and things has relations to other things. Nothing stands alone in this world. Everything has a relation to something. Sorry, I'm getting tired. My tongue is fooling me. So directed graphs, the arrow goes in one direction. Data is described as triples. It consists of 3 things. And a triple is also called a fact or a statement. And here I say utsagn in Norwegian, but I always add that statement as the English translation for utsagn. The elements of a triple are called resources. A triple consists of 3 things, 3 resources: a subject, predicate, and object. And we use uniform resource identifiers to tell resources from another. And a URI is only a name, doesn't have to link to anything, even though it looks like a URL. But it's only a name, a global unique identifier. Skip that one. This is the triple. Everyone here knows how to read this. I will skip that one. And I talk about prefixes, and I visualize the triple. I talk about literals, plain strings, language tag strings, numbers, typed numbers, and booleans. And in this slide, I also get to sneak in those syntax flavoring, a semicolon and a comma. Very interesting distinction between languages here. And then, folks, we can draw. So now I want you to draw a knowledge graph and remember to draw objects or subjects, everything that can be described further as circles. So if this thing has a relation to something else, type it as a circle. If it's a data value, you put it in a square box and you type it. Type every single data value or language tag it. The arrows goes in one direction and they have a name, but we're not bothering about namespaces here. I also talk about namespaces, of course, in the turtle examples. But for you guys, you will not draw a graph in your domain of choice. You will draw a graph and talk to each other and draw together. You will draw a graph about what is a knowledge graph to you and what do you find important in a knowledge graph and the knowledge graph capabilities. So draw a graph about knowledge graphs. Since this is a meta workshop, we're drawing meta graphs. Okay, go for it. And you at home, draw a graph, same topic, same rules. And when you are done, you take a picture and you send it to me.
I like this color combination better. And this was the very last one to put together, and that's the best thing. Okay, if I wasn't clear enough, I want you to collaborate.
That's why it's 2 papers on the table.
No, to draw a graph. Yes, what is that about? Understand? So knowledge graph represent.
I can hear the mist turning into
Different. So capabilities of knowledge. So let's if you focus about but focus on the definition of what are the elements of the knowledge graph, what contribute to generate knowledge.
like we understand it's better if it's visual, but the more visual the better. At times it's like it's the most literal to help like having like a little bit of information, having like a diagram, stuff like that, with like things that indicate what's going on, or getting into that. Something that I'm interested in is like how can support this kind of operation.
That's good. Like for previous with reasoning.
And yeah, I want to learn how to cooperate with the employees and with the managers. I don't think we need to worry about that.
I'm writing down some of the scripts that you have.
Oh, are you on social media?
Yes, exactly.
Being intelligent. So you're saying.
The capabilities of knowledge graph. So in terms of functionality, knowledge graph helps decrease of inferences. Knowledge graph is represented as a graph with nodes. Knowledge graph.
Capgemini is the predicate. Yes. This is data. Data set. While name is data type, and it's object.
So you said application.
All the predicates that we have the range as string, they are data. Those who have range objects.
Do we have concept since we are doing are we avoid
Yeah, like find disconnections, and I want to like see if I
Predicate can be also all probably.
what's a node, what's a node.
Well, the problem is that it's so quick. Yeah, that's what I find difficult.
like if you were in the university, the domain, yes, anything regarding the university staff and so on. The domain there is knowledge graph. There's the application. An application and domain. An application is related to a domain. It could be science. We have different domains, so one billion application.
Okay, plot twist. There's a prize for the table with the most edges,
Oh.
and there is a prize for the table using the most colors.
Who's going down?
So there's a prize for
Most
most
edges,
edges,
most colors.
most colors.
So whoever has the most surplus.
So when I kind of transition, the first thing I did is forget about the relationships. I just, if someone mentioned this thing, that's what that is. So no relationships, just all the things, the concepts that I learned. And in general language, just like, you know, it down stuff, come across, put it down. And then when you see it, then you say, okay, then what's the relationship? What did you say? And then start filling in the lines at the edges, as she says.
But then I imagine, or like I guess like different people can understand different concepts belonging to different families. So I don't know, let's say shoe and phone belong to the same family, but someone else like shoe is like footwear and phone is like a those are two different concepts, but also we want to differentiate between the nouns and also we're gonna have like things like kind of get standardized of how they're. But I don't think we should use the same.
So the same name of the same concept, that is two different things. Or two different
Yeah.
Can you give an example?
Seriously, like, I'd say the reasoning and the query is probably what's like organized the application in the storage. The question would be like, is that something valid or
It's still I mean, I think it is valuable because people perceive the same thing in different ways. And when you put that out there, you may see contradictions, and that's valuable because because you want to coalesce into some common model instead of like if you're eventually putting it down to a system, you want the group to have some common notion of some collection of things. And then to have different views of it is valuable, like I said. Like, I'll give you an example, like two different people, two different departments have a certain notion of some business term that may be different, and that's valuable because their systems may reflect them differently. Maybe they should be the same, maybe not, but there's a relationship still between them, there's some nuance. So, yeah, I guess to address your question,
So we have tools. Point two.
People like say like different areas get to common or like at least like an knowledge graph to like good camps in one way. I mean, other thing is it'd be important for the people who like agree that that's like the way or that's still like the other like would you like be like or something that happens like
I mean, personally, I keep asking questions until, and have them talk to each other until maybe they get consensus between themselves without my intervention. Okay, well, what do you mean by this? Why do you see it differently? Oh, because we do this or whatever. And if they come to some consensus, then that's great. I don't have to do anything. And just help bring it up.
So it is still to have people like meet like every together and like they're different reasons. I haven't heard that for the first time.
So there's like
Yeah, actually,
a company and it's impacting whatever, but then it's impacting other people, right? So maybe there's the engineer that's actually impacting, maybe there's a salesperson because it's an application, like business, like different business. I don't know if that would be the word that would fit. Like, yeah.
You're also people also people who are using data like
Yeah.
or the modelers.
Yeah.
Maybe there's like fancy other things that come in there, like tools or
data structures or whatever you want to call it, and those are used to represent the domain. Then the house of that one.
Yes.
Yes.
Is the range,
Taxonomy.
Yeah.
So we can say, but there are instances of two actually, right? So that means that. So that's how we draw it. We use a different color. Use a different color, right? We just say that. Let's say.
okay, can we go to those then?
It's a tool, right? Type of.
Because if we're saying users, it's like, so for example, in these knowledge graphs, you salt water, right?
I think that's what.
There are the people actually doing the action of using the technology, and then there are the people that are the recipient of it. So I don't know what the, do you see what I mean? I don't know what the term would be.
That's like instantiation that
Yes, yeah, there we go. Like the.
is part of the.
So we need to find for
Kind
this
of,
one.
but I always get logic.
Yeah, because there's different, there's different,
You know, you have to
different,
try a different
there's
way.
people doing that.
Until you found the solve the puzzle.
Maybe they haven't done anything, but they're the recipient of.
And is it like something that happens
Whatever,
automatically
yeah.
on a computer? Why do we say?
So here we use a tree.
Like.
Oh, using vocabulary, like models.
You mean we have to work with the computer, we have to.
To like identify patterns.
But in this case, we are saying that it's way.
Yeah, both.
I would say.
Yes.
So the vendor that you know.
You could also, you could also be using
The user aspect. So yeah.
Can we call it the inside a different color?
If this is kind of part of.
Okay, everyone, you got 4 minutes left. So when this thing goes off, I'm gathering all the drawings, and make sure to state some kind of table name or group name, team name on the drawing.
I don't work for.
Should I do a subclass of that or the different thing? No, I read an
And I'm only accepting one drawing per table.
Lula talked about the water features. Part of what she was talking about is and when she's referring to the group that getting together for a contested coordination, which is a different project, they're involved in the grade supplying that water.
geological survey. So.
Yeah, I just went to go name logic.
You know, Dave.
Well, I met.
So there's like, there are people that are active in that.
I'm an outfit.
And then there are people that are.
Yeah, you know,
That's why stand up is
Just okay.
because for any application, you're using they're the people that actually are doing it, like they're applying. And then they may have an immediate, like an immediate benefit. There are people that benefit from it.
And the people that are working on it.
Yeah, that are also benefit, but it's a different benefit. You know what I mean?
Yeah.
Like end users, yes. Yes, thank you. Yes, thank you.
At least a few times.
Okay, so then that would be, I guess, it would be the stuff.
Yeah, what's your last name?
So you model
Yes.
a modeler is a user. It's a type of user. Yes.
In fact,
Yes, I guess like you said, to use something different.
Those are two types of user.
Yeah,
Okay.
yeah.
No. So that's a big group now. Okay.
So then they would be like, so two types of users. Yeah, sure.
Yes. Yeah.
Yeah, here, yeah.
Okay, so you have user, end users and model.
unless you want to take the seating, because we use for agents,
Yeah.
which is nice. Takes the whole
Just one?
In fact, USGS is for the, we just started this new collaboration, they're funding over the next 5 years. They're just crossed. How many did you connect from?
Thank you.
Which makes a lot of sense because if you think about water data sources across the United States, USGS data sources all over the United States. It makes sense to have like this index of all the sources together.
Does it matter like how you?
And then you said the model.
Time's up.
Change their model.
Okay, everyone, give me your drawings. Have you stated the team names?
We already have model.
Team names. Original. Drawing. Awesome. Thank you. Drawing. Drop your pencils. Okay. Drawing at this table. Is it representative? Okay. Yeah. Nice, nice, nice. Awesome. Thank you. Drawing. Thank you. Drawing. Thank you. Okay. Silentium, silesium, as we say in the Science Association at the University of Oslo. Okay, so this activity, this is something I do together with my client when scoping up the very tiny beginning of an ontology. Building an ontology is an iterative process. So this drawing is on the table several times. But in my workshops, especially if it's one client drawing stuff with their domain knowledge, this is a gold mine. Taking in every single drawing made during that workshop gives me a lot of information about that client, being able to scope their use cases and bring that on the table for the next time we meet. So thank you so much. So let us have a look. So now you have helped me to refine and improve my workshop. So this, what's the name? Duff? I think it was from you guys back there. Okay, so I'm not going to, I'm just going to lay them down for a first impression of the number of edges and colors. It's a clear winner. So here we have the most amazing Norwegian Kit Kats, and you definitely have both the most edges and the most colors. So here you go, guys. Okay, thank you. And those following online, please take a picture of your drawing and send it to me. And I will picture these and I put everything on GitHub. The presentation, I'll put on GitHub. Resources, I'll put on GitHub. The code examples, I'll put on GitHub. And your contribution, I'll put on GitHub. It's a pity I can't put coloring pencils on. Okay. Closing remarks. Yeah. I have 2 extra slides. I also cover blank notes and collections or lists in my workshop because that's needed for talking about axioms and shapes later on. But yeah, so this is pretty much it. I don't know if I have any wise words to end with. Thank you for making me able to look inside your brain. Thank you for attending. I hope it was useful in some way. And see you around at the conference.